Hello and welcome to 1.7, Properties of the Real Numbers. Now we're going to be getting into algebra, and I'm going to be finding some of the properties of the real numbers and some algebraic properties here. So what I'm going to do is I'm actually going to be looking down here and kind of relating these back to these things that we have up here. Excuse me. So in this first equation right here, notice we have a 6x plus 3 plus 8x. Over here we have 3 plus 8x plus 6x. What's happened between the left side and the right side? What's happened between the left side and the right side is the terms, and these are individual terms, we call that a term, that a term, and that a term, have been moved around. That is classically called the commutative property. And that's right here. So the commutative property works for addition and multiplication, and really what it says is that 4 times 3 equals 3 times 4. That is, you can multiply in any order that you want. And it also works for addition. That is, 4 plus 3 is the same as 3 plus 4. So the order, when we're dealing with order, that's the commutative property. Okay, now let's look at the second one here. Now notice, first we have 4, and then in parentheses, xy. On the right side, we have 4x in parentheses and y. Now, has the order of these terms changed, or the order of these symbols changed? 4x and y, 4x and y. The order hasn't changed, but the grouping of these. First, we're grouping the x and the y. Second, over here on the right, we're grouping the 4 and the x. This is the associative property. And what that is that we can group things with addition and multiplication any way we want. That is, 4 plus 3 plus 7 in parentheses is going to be the same as 4 plus 3 plus 7. And you can verify these things if you want, but they are in fact true. Okay? Now, the third property right there, we have 3 times 1x equals 3x. Well, 3 times 1 is 3. So that 1, that is known as the identity property of 1. So identity. That is, the identity of property of 1 states that 1 times anything is just that thing. So like 4 times 1, that equals 4. 1 times 7, that equals 7. So 1 times anything is just the thing that we're multiplying. Okay. Now we look at number 4. On the left side we have 9, and then in parentheses we have a plus b. On the right side, in parentheses, we have 9, parentheses, ba. So did the order of things change? Well, yeah, the a and b have swapped places. So this is commutativity again. C-O-M. Commutativity. Okay. Now, this fifth one right here, notice we have 4 and then in parentheses 2x minus 1. On the right side we have 4x minus 1. What this is known as the distributive property. And what we say is distribution occurs over addition and subtraction. So if we look at the left side, how we can get the right side is we go 4 times 2x. Well, 4 times 2 is 8. That gives us our 8x. And then we could say 4 times negative 1. That's negative 4. So we've distributed this 4 into the 2x. We've distributed it into the negative 1. That is how we distribute. This is the distributive property. So what the distributive property says is that if we have a times b plus c, we can multiply the a times the b. That's going to give us ab. Then we have the addition, so we have plus. And then we can multiply the a times the c, so we have ac. That is distribution. Okay? Now, the next one here, we have a plus 0 equals a. And this is just like number 3, where we have 3 times 1x. 3 times 1 is just 3. Here, a plus 0 is just a. So this is the identity property for 0. So the identity for 0, which is to say that if we add 0 to any number, we get that number back. So 4 plus 0 equals 4. 0 plus 7 equals 7. That is that property exactly. So let's look at these next two. Here, in number 7, we have 1 plus 2 plus 3 and the 2 plus 3 in parentheses. On the left side, we have 1 plus 2 in parentheses plus 13. Not 3 over there, 13. So has the order changed? 1, 2, 13, 1, 2, 13. The order hasn't changed. If the order changed, it would be commutative. What's happening is the grouping has changed here. First, we're grouping the 2 and the 13. Second, we're grouping the 1 and the 2. This is the associative. Okay? And then finally, number 8 right here. If we have 3 plus 6x times 2 on the left, and we have 6x plus 3 times 2 on the right, well, what's happened? What's changed between the left side and the right side? Well, what's happened here is the 3 and the 6x have moved spots. When we're moving spots and changing the order, that's the commutative. That is the commutative property right there. So a couple things that I want to point out that we didn't define up here that still need definitions is factoring. Now, factoring is nothing more than the opposite of distribution. That is, if we look at number 5 again, if we have 8x minus 4, wow, that's really kind of terrible. Let me erase that and start over. Okay. So if we have 8x minus 4, distribution sends the 4 in. Factoring would bring the 4 out. Now this, we can divide that by 4. This, we can divide that by 4. So we can pull the 4 out. And what happens is when we divide 8x by 4, 8 divided by 4 is 2, so we have 2x. If we divide negative 4 by 4, that's negative 1. This is factoring. So if we go in this direction, it's distribution. If we go in this direction, it is factoring. Now, an expression is nothing more than a set of numbers, letters, yikes, and operators. So operators are like addition, subtraction, multiplication, division. Letters are variables, and numbers are just numbers. So everything that we've seen down here, essentially, each side of these is an expression. Now, this is an expression, that's an expression. When we put the equal sign between them, we have an equation. So just one side of an equation, that's like an expression. So we have 4xy, that's an expression. 4xy, that's an expression, and so forth. Now, equivalent expressions, two expressions are equivalent if they evaluate the same for every number. So notice we have 2 times x plus 1, and we have 2x plus 2. These are said to be equivalent because it doesn't matter what number you put in for x here. If you put the same number in there, you're going to get the same thing. So notice, if you put 1 in, 2 times 1 plus 1, this is 2 times 2, that's 4. Plug it in here, 2 times 1 plus 2, that's also 4. And that would continue on, and that's what equivalent expressions are. Okay. So, now we'll go down, excuse me, to the next one. So now what we're going to do is we're going to move into the practice with this. So it says write 2 equivalent expressions for 11 plus AB. So we want equivalent expressions for 11 plus AB. So one equivalent expression, we could have AB plus 11. And that's using the commutative property right there. Another thing that we could do is we could say 2AB plus 11 all divided by 2. Because these 2's would cancel out and they would give us the AB plus 11. So that's one way to think about it. Now, over here, when we're finding an equivalent expression with a given denominator, we want to think about what is down here and then what's down here. And we want to think about what's up here and what needs to be in the numerator there. So if we have 8, how are we getting 8t? What's missing from this side that's over here? Well, the t is. So really, to get from the left side to the right side, we're multiplying numerator and denominator by t. When we multiply 5 by t, that just gives us 5t. Now, if we look over on for letter B here, you'll notice that we have 4 over 9x. Here we have 9x, here we have 18xy. So what do we need to multiply 9 by to get 18? Well, whatever we multiply the denominator by, we need to multiply the numerator by. So if we multiply the 9 by 2 to get that, we have to multiply our 4 by 2 to get 8. We have our x and we have our x over here, so we don't need another x, so that should be okay. Oops. Scratch that. We have our x, we don't need an x, so we need to cross that x out. We have our x, so we don't need one of those. But we're missing the y, so we need the y right here. So I know this is a little convoluted, but let's go over that one more time. If we have 4 over 9x equals something over 18xy. To get from our 9 to our 18, we need to multiply by 2. 2 times 4, 8. So we have our 8. Here, we already have the x, so we don't need an x over here, so we're good with the numerator not multiplying by x. But we're missing the y, so we have to multiply the numerator by y. So we have an 8y there. Okay, so hopefully that made some sense to you. Now, the next set of things that we're going to do is we're going to use that property of distribution to do some multiplication. So when we simplify this, we want to get rid of the parentheses. So the way we do that is multiply in 4 times x, that gives us 4x. Then we multiply 4 times 5, plus 20. And we've distributed the 4 in. So the 4 has gotten to the x. That gives us our 4x. The 4 has gotten to 5, gives us our 20. And we're good. Same thing on the second one. We're going to distribute the 3 in. 3 times 2x. 3 times 2 is 6. So that's going to give us 6x. Then 3 times 9, that's 27. So plus 27. That is what we have going on here. And I'm going to erase that. It looks like a minus sign. 3 plus, there we go. So we have our 6x plus 27. Same thing here. We're going to distribute our 22 into our x, giving us 22x. Substitute, multiply our 22 and our negative 3, negative 66. And we're good there. Same thing down here. We're going to go ahead and distribute into here. Negative 2 times x, that's going to give us negative 2x. Negative 2 times negative 2y. Well, negative times negative is a positive, so that's a plus 4. And we have our y tags along. And sorry, my y's look a little bit like 4s. So I usually put the little tail on the y to denote, in fact, it is a y. Now this one here, what I want you to notice is there's an invisible 1 on the outside here. When there's nothing on the outside parentheses, it's 1. So we're using that identity property for 1 again in distribution. 1 times y is y, so that's y. 1 times negative 12 is negative 12. And that's what we have right there. So that's what we're doing. Okay? Excuse me. So, last thing we have going on here is we are going to combine some like terms. Now, like terms have the same variable parts. To do this, we just add the coefficients together. Now, a coefficient is the numerical part of the number, of the term. So this 4x, 4 is the coefficient, x is the variable. Here, the 7x, 7 is the coefficient, so we do that. So here, if we have 4x and we take 1x away, 4 minus 1 is 3. So that's 3x. Excuse me. Over here, with our like terms, we have 7x minus 4x plus 1x. So combining the like terms here, if we have 7x minus 4x, 7 minus 4, so right here, that alone gives us 3x. So we still have plus 1 more x. 3x plus 1x is 4x. So all combined, that in fact is 4x. Now, on this next one, we want to identify the like terms. That is, we have a 3w and a 5w. Those are like terms. And then the 13 and the negative 10, those are also like terms because they don't have any variables. So the w's we combine like we think we would. 3w's plus 5w's. 3 plus 5 is 8. That gives us 8w. 13 minus 10 is 3. So plus 3. And that's what we have. So there you go. Next time we'll see you for simplifying expressions in order of operations.